I'm a math teacher. I'm a math teacher. 'Cause I know sometimes students like to hate. So why don't you listen, 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 listen. And I'll teach you math, math.
Please excuse this interruption. We'd like to thank everyone for attending Stevenson Middle School's parent conference night. At this time, our conferences are over. Please make a commitment to future communication with a phone call or an email. Please finish up your conversations and give our teachers an opportunity to head home for the holidays. Thank you and have a great night.
Spring break! Oh! Math rocks.
Work hard, reap what you sow, reap what you sow. Work hard, reap what you sow, reap what you sow.
Oh, here I am, at home.
Hi! Now you say, I'm home. Will you help me solve equations? Will you help me solve equations? I'm back from spring break. Let's solve equations. You want to? You say yes. Please.
No.
Please.
No.
Pretty please.
No. Delaney, I'll give you a candy
Katie game?
Yes.
Can you help solve equations? Say yes.
Delaney, say yes.
Is that a yes? Is that a yes?
Yeah.
All right. Let's solve some equations.
Alright, welcome to my first video. This is going to be awesome. It may not sound like this, you'll kind of hear it in the video, but I'm actually shooting outside. So if you do hear some other things outside, that is because it may look like I am somewhere else, but I'm actually outside with my green screen. Shimmied it up a little bit. It may not be the best of quality, but we're just going to make do with what we have. So again, this is going to be on solving equations. And so the first thing we're going to look at is the first way that we learned on how to solve equations. So let's get at it. All right, so the first problem that we used to solve equations was bags and coins. So first off, what we're going to have are bags, all right? And so we don't know what's in those bags. And then the second thing we're going to have are coins. And we're going to know, right? In this case, we have a penny here. 1 penny is 1 cent. Now, the challenge is that in the bags, there's going to be a number of pennies, right? What the question is how many pennies are in each bag? Each bag has the same amount, but we don't know what that amount is. So it's a mystery amount, which I'm so excited to try to find, and I'm sure that we are excited to find. But we're trying to find out how many coins are in each bag, and we don't know how many, all right? And so we're going to come up with this problem to try to figure that out. So first problem is going to be 2x plus 9 equals 23. So what that means is that we have 2 bags, bing, bing, and we have 9 coins, right, on one side. And then on the other side, we have 23 coins, all right? So 2 unknowns with 9 coins. And we want to know how much is that equal to 23 coins over here. How many coins have to be in each bag? And so what we see is, and Delaney will be my helper here, is that if we want to, and this is our first main key right here, is that you have to get the unknown value by itself. You have these 2 bags with these 9 coins. You don't like both things on one side. So you want to get those 2 bags by itself. And so how we're going to get those 2 bags by itself is by getting rid of those 9 coins. But if we get rid of 9 coins on one side, we got to get rid of 9 coins on the other side. And so here, Delaney's going to help us, as you can see here on the screen. All right, so she's going to get 9 over here, and then she's going to get 9 over here, and then bam, we're going to take those 9 away. Now, once those 9 are away on both sides, now we have 2 of the unknowns equals 14 of the coins. And so now that that's by itself, we can say, all right, divide it by 2, and so x equals 7. So each bag should have 7 coins in each bag. And now it also does is to go back to the original problem, right? So the 2 bags with the 9 coins and the 23 coins over here, and now put that 7 back into our bags and see, does that work? So if we change those 2 bags right up here to 7 coins, sure enough, 7 plus 9 will also equal the 23 coins over here. And so sure enough, it did work. And so this is the first problem. And again, it's not so hard. You're like, why are we doing this? It's not so hard. But now let's make it harder. All right, so now we're on the second problem. And so now we're going to start off with somewhat similar here. So we're going to have the 2x plus 9 on this side. But instead of the 23 coins on this side, now we're going to have is 5x plus 3. Right? 5x plus 3 is going to be on this side. And so how this is harder is that now we have 2 bags on both sides. Not only coins on both sides, but bags are on both sides. But now what we want to do is, just like what we said before, is our first main point for how to solve equations is you have to get the unknown by itself. And so we still want those bags on one side and the coins on one side. And so to do that first is we want to go back and make the problem just like it was before. So we want to get rid of the bags first. So that means we're just going to have a problem just like it was before. So if we have these 2 bags here, we have to get rid of 2 bags here. And if we get rid of 2 bags on this side, then we got to get rid of 2 bags off on the other side. And so now the one big mistake though happens though, and this is what we want to see, is if you take away 2 bags, you have to take away 2 bags on the other side. Do not take away 2 coins. Bags and coins are different. So if we have this to say, right, bags are going to be our unknowns, our variables. The coins are going to be our numbers. We know what the values of those numbers are. And so there's a big difference between an unknown number and a known number. So there's a big difference between bags and coins. There's a big difference between X's and numbers. So please make sure that you have that difference, that again, you can't combine bags and coins. You can't combine X's with numbers. X's go with X's, numbers go with numbers. And is this a huge mistake? Yes, and we're not even going to make this as a bullet point, but this is still a big idea, right? And then we call those like terms, that you have to combine the like terms. Bags with bags, coins with coins. This case, it's X's with X's, numbers with numbers. So we take away 2 bags over here. We do not take away 2 coins, we take away 2 bags. And so instead of 5 bags, now we're left with 3 bags, 3 unknowns. And so now it's a problem like it was just before. We have 3 unknowns with 3 coins over here, and then we have 9 coins over here. And now now it's just what changes, right? I'm moving all the different ways, is that now we have to get rid of the coins on this side to get the bags on by itself over here. And so we have to get rid of the 3 coins on this side. And so if we get rid of 3 coins on this side, we have to get rid of 3 coins over here. And so now this is only 6 coins, but now it's 3 bags. And so now you take 6 divided by 3 is 2. So now in this case it was 7 before, but now it's a different problem. And so that unknown value in this case is 2. So again, going back to the whole step, is that first thing is that getting the variable by itself. That's the main key here, is getting the variable by itself. And how we do that is, again, getting rid of things on both sides, but also remembering that, again, bags and bags, coins and coins. So there's really 2 main ideas that we pull out from this idea. And again, I know I'm talking fast, so again, if you need to hear this again, please just rewind the video and do it again. I know I'm speaking fast. You could even go on YouTube and hit that slow button, so I'll even talk even slower. All right, so thank you. Watch that again. And now we're on to problem number 2. All right, so now for our second problem, what we're gonna do is go, and this is not gonna be as long, so, all right, but this is just a bags and coins. So right here behind me, we have a scale, right? So it's even. And so now my son is going to help us on this one, right? So we have some of my sons that go on this side and go on the other side, right? Now what happens is what if you do to one side, you have to do to the other. So if you add something to one side, so here, just one of my Cayman, right? One of my Caymans over here. Now if we add more, you have to add more on the other side. If you subtract, right? If you subtract some of them, you have to subtract the same on the other side. Now what happens if you subtract something and then you take that same thing but you add it to the other side, it's not going to be balanced, right? And this is what we do not want to see happen, right? So if we have a high weight scale, we take something off and we put something heavier, maybe we make this side lighter and then this side a lot heavier, but then boom, no! All right, so hopefully I had that special effect to work. We'll see how well it works. But Cayman was supposed to be going flying off. Hopefully, right, if you don't do that, right, if you add to one side but then you take away from the other side, then it's not going to be equal. So it's the same thing with your equation. So we had 2 main points in the last one. So our third main point in this one is what you do to one side, you have to do to the other side. Otherwise, it's not going to be equal. Whether you add or add, whether you subtract, whether you multiply or multiply, whether you divide or divide, you have to do the same thing to both sides.
Emergency, emergency! I forgot to mention one big idea, and that's a huge big idea. The fourth one is, how do you get rid of things, is using inverse operations. So we've been doing addition, hey, how do you get rid of like +4 coins? You have to subtract. Well, let's say if you had a -9, how do you get rid of a -9? You have to add. So add and subtract are inverses of each other. Multiply goes with divide. But also, right, if you had 3x with 6, you divide it by 3. But what if you had x divided by 8? How do you get rid of divide by 8? You multiply. So have to use inverse operations. That's our fourth one, and it's important. Okay, our emergency over.
All right, so the final problem. What the final problem will be about is the double number line. Now, if you're just watching this video and you've never seen a double number line, you will have to go and look that up, because for those of us who watch and have been in my class, we're going to know what it's about. But then for those of you who have no idea or whatever you are seeing this video, you will not. So you do need to go see double number line. It's a little bit harder. And again, you see the problem on behind me, but where I'm at, I'm not able to see anything. So now what we're going to do is, instead of being on the positive side and moving to the left, now what we're going to be on the negative side. So we're going to start over here on that. We're actually going to put the 0 far over here, and then start over on the negative side. So the first one will be negative 5x plus 8. That'll go on the top, and then we'll have 2x minus 13 on the bottom. And so now what we're going to do is the same thing, right? We want to get the x's away first, right? We want it to be the problem the simplest. So we don't like variables on both sides. We're going to get rid of the 2x. And so how do we get rid of that 2x? And again, you could have already gotten rid of the minus 5x as well. But again, there's so many ways to solve this problem. So if you minus the 2x, that's going to lose the value. So if you lose value, go this way. So Linnea, hopefully you can push that one this way. And now we have, if we lose 2x on this side, on the bottom side, then that minus 5x, if you lose 2x on that side as well, now it's minus 7x. And it still has that plus 8. So it's minus 7x plus 8, and then on the bottom it's minus 13. And now what we want to do is get that variable by itself. So how do you get rid of the plus 8? You have to minus 8. And so it's going to lose another value over here as well and get more negative again. And so now the minus 7x plus 8 is just minus 7x. And now the minus 13, and you subtract 8 more, now you're at minus 21. And so now we're finally got to the moment where it's just the variable on one side and the known number on the other side, and now you can divide. It's a negative 7x and a negative 21. When you divide by a negative, though, this is where it's going to be tricky, right? We've lost value, we've lost value, we lost value. But when you divide, you're actually going to make the value smaller, right? 21 divided by 7 is 3. But when you take a negative divided by a negative, it's also positive 3. So now it's 21 is 7, but now 1 is 3, but it's not negative 3, it's positive 3. It's actually on the other side of 0. Whenever you multiply or divide by a negative, all you do is you switch sides, right? So we subtracted, we lost value, we divided. When you usually divide, when you divide by a whole number or a big number bigger than 1, you're going to lose value. But this case, not only did we lose value when we divided by a whole number, or again, when you just, in this case, it's just divided. We actually even switch sides to the other side of 0 is when you multiply or divide by a negative. So again, another thing to throw at you. And again, we practice this a lot in class. And again, if you haven't done this, I would definitely practice this with double number lines and try to solve problems with double number lines. They're really great.
That's why I made a classroom set.
And then now, again, watch these videos a couple times. This is pretty crazy, pretty hard stuff. And again, thank you, Linnea, right, of pulling these numbers to help us out here. Now we're off to the last problem. All right, so on this side, we have this problem. And now what we're going to do is get more difficult. Just like it was before at the beginning, right, we started the very first problem, right? It was 2x plus 9 equals 23, right? We just had one variable. And then what we made it harder is we said, well, let's just have 2x plus 9. But instead of 23, let's put 5x plus 3 on there. And we made it even more difficult. And so now we don't have a scale, all right? We don't have a double number line. We don't have... the bags and the coins. Now it's just all abstract, right? And so this is the most difficult one you're going to get. And so what you want to do is just make it like a problem that we've done before. So, ready, all right, and again, if you're not ready, rewind, and watch it over. Practice more. Go to Khan Academy, get some more practice. So, we have this on here. The problem is 6x minus 2 times 5x minus 5 in parentheses equals, now the other side, is 8 minus 2 times x plus 12. And so what you have to do is you want to make this problem like, and so there's got a couple of things. First off is distributive property. So we've talked about distributive property, and again, if you haven't watched or been in my class, look at distributive property. And then you want to combine like terms as well. So first thing is distributive property. When you have those parentheses, you have to multiply. So on the left side of this equation, that minus 2x times 5x minus 5, you have to distribute that minus 2. So that 2 is subtracting that whole thing. So you multiply everything by 2, but also you carry that minus sign with it. So the negative 2 times 5 is minus 10x. Then that negative 2 times negative 5 is positive 10. And so on that left side, now we can have the next spot is 6x minus 10x. Well, what is 6x minus 10x? Those are like terms, right? Those are bags and bags. But again, 6x minus 10x is minus 4x. And we still have that plus 10. So now we've simplified everything on the left side. So the left side is now negative 4x plus 10, right? Now we have to do the same thing to the right side. But you can see is that once you distribute and combine like terms on each of the sides, now we're going to be left with is just another type of problem like we did on that double number line, where there's a variable and a number on one side and a variable and a number on the other side. And then we just got to get the variable on one side and the number, the known number, on the other side. So let's look at the other side. So we have that minus 2 again on the other side, so we have to distribute that. So minus 2 times x is minus 2x, and then minus 2 times 12 plus 12 is minus 24. Now that minus 24 combines with the minus 8, because those are the numbers without a variable. Those are the like terms. Those are the coins, right? You know the value, so you can combine those together. So minus 8 minus 24 is minus 32. And so that side becomes minus 32, and then you have the minus 2x. And so we have minus 2x minus 32 on one side, minus 2x minus 32 on one side, and then on the other side we have minus 4x plus 10. So we want to, let's say, now we want to get the variables by itself. Do we want to move the minus 4x, or do we want to move the minus 2x? Let's just move the, let's just move the minus 2x. So how do you get rid of minus 2x? You add 2x. So on that right side, how do we get rid of that minus 2x? We add 2x. So if you add 2x, that's gone, but then we have to add 2x on the other side. And so that minus 4x now becomes minus 2x, because minus 4x plus 2x is minus 2x. And then that side also has that plus 10. So how do you get rid of plus 10? You have to subtract 10. So we subtract 10 on one side, we have to subtract 10 on the other side. And so what's on the other side right now is minus 32, but when you subtract another 10, that becomes minus 42. And so now we have minus 42 on one side, and then on the other side we have minus 2x on the other side, and so x has to be positive 21, right, when you divide
Negative 2.
21. And can you go back to the original problem and check that all out? Yes, but that's the whole story of solving equations, and it's again a big story. Hope you enjoyed the ride. You know, my kids helped. Thank you for my kids, my wife, my family helping us out. Again, math rocks. Hopefully these cool videos will help as well. Thank you. Math rocks.
Keep video going. We'll dance together.
Ah!
Alright, stop. Alright, stop.
Nope, and you gotta just stay there though and walk like this. Go. And start like you're pulling it back like this. Yeah. Oh, okay. Alright, then start to get in the middle again. Alright,